The National Electrical Code, or NEC, defines bundled conductors in section 310.15b3 as two or more conductors in an overcurrent device or wiring device that are connected in parallel, or conductors that are physically tied, bundled, or twisted together. Now let's consider the NEC requirements specifically for bundled NMB cables. NEC section 520.2 addresses conductors in raceways, cable trays, cables, or cords. It mandates that these conductors must be derated in accordance with table 310.15b2 if the equipment is operating at temperatures higher than those for which it is approved. However, there's an exception. NEC section 310.15b3 explicitly states that derating is not required for multiple conductors in an assembly approved for the number of conductors. An NMB cable with two or more conductors falls under this exception, particularly in single-family dwellings where the number of conductors is not more than 3 in a cable. It's important to understand that inspectors may interpret NEC sections 310.15 and 520.2 differently. Some inspectors might require derating for 2 or more NMB cables running through a stud hole, while others may not. There's no universal consensus, and local interpretations can vary. Cable spacers are not strictly required between studs for NMB cables according to the NEC. However, their use is a good practice. Cable spacers can significantly improve cable organization and prevent cables from rubbing against each other. This rubbing can potentially damage the insulation over time, so spacers offer an added layer of protection. To avoid potential issues with inspectors and ensure the safest installation, it's recommended to derate NMB cables that are bundled together in stud holes, even if it's not technically mandated by the NEC. This proactive approach can help you avoid disagreements and ensure compliance. You can determine the appropriate derating factors by consulting table 310.15b2 in the NEC. This table provides specific derating factors based on the number of current carrying conductors in a bundle. In summary, firstly, understand the NEC definition of bundled conductors and how it applies to NMB cables. Secondly, be aware that inspector interpretations can vary, so it's best to err on the side of caution. Thirdly, consider using cable spacers for improved organization and protection. Fourthly, when in doubt, derate NMB cables that are bundled together in stud holes to ensure compliance and safety. It's also worth noting that the type of NMB cable you are using can affect its ampacity. For example, an NMB cable with a temperature rating of 90 degrees Celsius can be used at its full ampacity if the terminations are also rated for 90 degrees Celsius. However, if the terminations are only rated for 75 degrees Celsius or 60 degrees Celsius, the ampacity must be adjusted accordingly. It is also important to note that the number of current carrying conductors in a cable assembly affects the ampacity. For example, a 2-conductor NMB cable has a higher ampacity than a 3-conductor NMB cable of the same size. This is because the heat generated by the conductors in a 3-conductor cable is more concentrated, and the cable must be derated to prevent overheating. When running an NMB cable through stud holes, it is important to ensure that the holes are properly sized. The holes should be large enough to allow the cable to pass through without being pinched or damaged. The NEC requires that the holes be drilled in the center of the stud and that they be at least 1 and 1/4 inches from the edge of the stud. This helps to prevent the stud from being weakened and also helps to protect the cable from damage. When installing an NMB cable, it is also important to use the correct staples or cable ties. The staples or cable ties should be sized appropriately for the cable and should be installed in accordance with the manufacturer's instructions. The staples or cable ties should be spaced no more than 4 and 1/2 feet apart for horizontal runs and no more than 12 inches apart for vertical runs. This helps to support the cable and prevent it from sagging or drooping. It is also important to avoid running NMB cable in areas where it is exposed to physical damage. For example, an NMB cable should not be run in areas where it could be stepped on or run over by vehicles. If an NMB cable must be run in an area where it is exposed to physical damage, it should be protected by conduit or other means. When splicing NMB cable, it is important to use the correct connectors. The connector should be sized appropriately for the cable and should be installed in accordance with the manufacturer's instructions. The connector should be listed for use with NMB cable and should be installed in a junction box or other enclosure. It is also important to ensure that the splices are properly made and that the wires are securely connected. This will help to prevent loose connections, which can cause overheating and fires. When terminating NMB cable at devices, it is important to use the correct terminals. The terminals should be sized appropriately for the cable and should be installed in accordance with the manufacturer's instructions. The terminal should be listed for use with NMB cable and should be installed in a device box or other enclosure. It is also important to ensure that the wires are properly terminated and that the screws are tightened securely. This will help to prevent loose connections, which can cause overheating and fires. When working with NMB cable, it is important to follow all safety precautions. Always disconnect the power before working on any electrical circuits. Wear appropriate personal protective equipment, such as gloves and safety glasses. Use caution when working with sharp tools and avoid working in wet or damp conditions. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Furthermore, it is crucial to differentiate between NMB cable and other types of electrical cables. NMB cable, often referred to as Romex, is a non-metallic sheath cable commonly used for residential wiring. It consists of two or more insulated conductors enclosed within a non-metallic jacket. Other types of cables, such as THHN/THWN, are typically installed in conduit. THHN/THWN conductors are single wires with individual insulation, designed for use in raceways. Understanding these distinctions is essential for selecting the appropriate cable for a given application. Another important consideration is the ampacity of the NMB cable. Ampacity refers to the current carrying capacity of a conductor, measured in amps. The ampacity of NMB cable is determined by the size of the conductors and the temperature rating of the insulation. The NEC provides tables that list the ampacity of various sizes of NMB cable at different temperature ratings. It is crucial to select NMB cable with an ampacity that is sufficient for the load it will be carrying. Overloading a cable can cause it to overheat and potentially lead to fire. In addition to ampacity, it is also important to consider the voltage rating of the NMB cable. The voltage rating indicates the maximum voltage that the cable can safely handle. NMB cable is typically rated for 600 volts, which is sufficient for most residential applications. However, it is important to verify the voltage rating of the cable before installing it, especially if it will be used in a commercial or industrial setting. When installing NMB cable, it is important to follow the NEC guidelines for support and protection. NMB cable must be supported at intervals of not more than 4 and 1/2 feet and within 12 inches of boxes, cabinets, and fittings. The cable must also be protected from physical damage. This can be achieved by running the cable through conduit or by using cable guards. It is important to protect NMB cable from physical damage, as damage to the insulation can create a shock hazard or a fire hazard. When running NMB cable through walls and ceilings, it is important to follow the NEC guidelines for fire stopping. Fire stopping is the process of sealing openings in walls and ceilings to prevent the spread of fire. NMB cable that passes through fire-rated walls or ceilings must be fire stopped with an approved material. This will help to contain a fire and prevent it from spreading to other areas of the building. When working with NMB cable, it is important to use the correct tools. A cable stripper is used to remove the outer jacket of the cable without damaging the insulation of the conductors. A wire stripper is used to remove the insulation from the ends of the conductors. A crimping tool is used to attach connectors to the ends of the conductors. Using the correct tools will help to ensure that the connections are secure and that the wiring is safe. Finally, it is important to remember that electrical work can be dangerous. If you are not comfortable working with electricity, it is best to hire a qualified electrician. An electrician has the knowledge and experience to safely install and maintain electrical wiring. Attempting to do electrical work without the proper training can be hazardous and can potentially lead to serious injury or death. When it comes to interpreting the NEC and applying it to specific situations, consulting with a qualified electrical inspector is always a wise decision. Inspectors are familiar with local codes and interpretations and can provide valuable guidance to ensure compliance. Remember, the NEC is a complex document and interpretations can vary. Seeking expert advice can help you avoid costly mistakes and ensure the safety of your electrical installations. Let's delve deeper into the practical considerations of derating NMB cables. Derating is the process of reducing the ampacity of a conductor to account for factors such as ambient temperature and the number of current carrying conductors in a raceway or cable. The purpose of derating is to prevent the conductor from overheating and potentially causing a fire. When NMB cables are bundled together in stud holes, the heat generated by the conductors can become concentrated, which can raise the temperature of the cables. This increased temperature can reduce the ampacity of the cables. To determine the appropriate derating factor, you need to consult Table 310.15b2 in the NEC. This table provides derating factors based on the number of current carrying conductors in a raceway or cable. For example, if you have 4 to 6 current carrying conductors in a raceway or cable, you would need to derate the ampacity of the conductors by 80%. This means that you would only be able to use 80% of the rated ampacity of the conductors. It is important to note that the derating factors in Table 310.15b2 are based on the assumption that the ambient temperature is 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is higher than 30 degrees Celsius, you will need to further derate the ampacity of the conductors. The NEC provides a table that lists the temperature correction factors for various conductor insulation types. To determine the appropriate temperature correction factor, you need to know the insulation type of the NMB cable and the ambient temperature. For example, if you are using NMB cable with a temperature rating of 90 degrees Celsius and the ambient temperature is 40 degrees Celsius, you would need to multiply the ampacity of the cable by 0.91. This means that you would only be able to use 91% of the rated ampacity of the cable. In addition to derating for ambient temperature and the number of current carrying conductors, you may also need to derate for other factors such as voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction or not operate at all. The NEC provides guidelines for calculating voltage drop and for selecting conductors that are large enough to minimize voltage drop. To minimize voltage drop, you can use larger conductors or run the conductors a shorter distance. You can also use a voltage booster to increase the voltage at the end of the circuit. Another important consideration when installing NMB cable is the type of load that the cable will be serving. Some loads, such as motors and appliances, draw a large amount of current when they start up. This inrush current can cause the voltage to drop and can potentially damage the equipment. To protect against inrush current, you can use a circuit breaker or fuse that is sized to handle the inrush current. You can also use a soft starter to gradually increase the voltage to the motor or appliance. In addition to the NEC, there may be local codes and regulations that apply to the installation of NMB cable. It is important to check with your local building department to determine what codes and regulations apply in your area. Following all applicable codes and regulations will help to ensure that your electrical installation is safe and compliant. When installing NMB cable, it is important to use the correct wiring methods. Wiring methods refer to the techniques and materials used to install electrical wiring. The NEC specifies the acceptable wiring methods for various types of wiring. For NMB cable, the NEC typically allows the cable to be run exposed in dry locations. However, the cable must be protected from physical damage. This can be achieved by running the cable through conduit or by using cable guards. In wet or damp locations, NMB cable must be installed in a raceway, such as conduit. This will protect the cable from moisture and prevent it from corroding. When running NMB cable through walls and ceilings, it is important to follow the NEC guidelines for fire stopping. Fire stopping is the process of sealing openings in walls and ceilings to prevent the spread of fire. An MB cable that passes through fire-rated walls or ceilings must be fire-stopped with an approved material. This will help to contain a fire and prevent it from spreading to other areas of the building. When terminating an MB cable at devices, it is important to use the correct terminals. The terminals should be sized appropriately for the cable and should be installed in accordance with the manufacturer's instructions. The terminals should be listed for use with an MB cable and should be installed in a device box or other enclosure. It is also important to ensure that the wires are properly terminated and that the screws are tightened securely. This will help to prevent loose connections, which can cause overheating and fires. When working with an MB cable, it is important to follow all safety precautions. Always disconnect the power before working on any electrical circuits. Wear appropriate personal protective equipment, such as gloves and safety glasses. Use caution when working with sharp tools and avoid working in wet or damp conditions. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Finally, let's reiterate the importance of ongoing maintenance for electrical systems. Regular inspections and maintenance can help to identify and correct potential problems before they become serious. It is recommended to have your electrical system inspected by a qualified electrician every few years. During an inspection, the electrician will check for loose connections, damaged wiring, and other potential hazards. The electrician can also test the operation of your circuit breakers and ground fault circuit interrupters, or GFCIs. By addressing potential problems early, you can help to ensure the safety and reliability of your electrical system. In addition to regular inspections, there are also some things that you can do yourself to maintain your electrical system. For example, you should check your electrical outlets and switches regularly for signs of damage. If you find any damaged outlets or switches, you should replace them immediately. You should also avoid overloading your electrical circuits. Overloading a circuit can cause the wires to overheat and potentially start a fire. To avoid overloading a circuit, you should make sure that you are not plugging too many appliances into the same outlet. You can also use a power strip with a built-in circuit breaker to protect against overloading. By following these simple tips, you can help to keep your electrical system safe and reliable. The goal is to ensure electrical installations are safe, compliant, and function effectively for their intended purpose, thus promoting the well-being of individuals and the integrity of buildings.